Okay, in this question, Exante trains are 50 kilometers faster than the Paral passenger trains. A Paral train requires 60% more time than the Exante train to travel 1,800 kilometers. It asks us to calculate the speed of the train. So the very first step is I'm going to draw the chart for this one, okay? So bear with me on my messiness. E stands for our Exante trains, and P will be our Paral trains. Oops. And here's my chart. The first column will be our distance, second will be our speed, and third column will be our time. So distance traveled by both train is 1,800 kilometers. And it says that the Exante trains are 50 kilometers faster. However, this Paral train therefore will take 60% longer. So any change that occurs in any of the trains, we want to assign to just one of the trains. So we'll say that the speed for the Exante train is s, and since Exante train is 50 kilometers faster than the Paral trains, Paral train must be 50 kilometers an hour slower than the Exante trains. Okay. Therefore, the time, because remember, velocity is equal to distance over time. Therefore, in order to solve for time, time is going to be distance over velocity. So we have our distance of 1,800 kilometers, our speed of s. So our time for the Exante train is going to be 1,800 divided by s. Now for the Paral train, this work is a little bit confusing for some of the students. By using this formula, we know that the speed for the Paral train is going to be 1,800 divided by s minus 50. However, we also have to take in consideration that it's going to take 60% longer. So what we want to do is, well, 60% in decimal is 0.60 multiplied by that time again, 1,800 over s minus 50. And just consider this 1,800 over s minus 50 as a variable, like say a and a. We have a coefficient 1 here, so 1 plus 1.6 is going to be 1.60 times by whatever this a value is, which is 1,800 over s minus 50. So therefore, this becomes our variable for the time for the Paral train. So it will be 1.6 multiplied by 1,800 over s minus 50. So what we now can do is we can set the time for the Exante train to equal to the time it takes for the Paral train to travel. And we'll substitute these formulas. For the Exante train, it's going to be 1,800 over s, which is equal to 1.6 times 1,800 over s minus 50. And since we don't want to work with fractions, we're going to multiply everything by, both sides by, this left side by, oops, I'm running out of tablet room, s minus 50, s minus 50 to get rid of that denominator. We're going to multiply the left side also by s to get rid of the s. And the right side also multiplied by s. Then when we expand this out, 1,800 times by s is going to be 1,800 s minus 50 times 1,800 will give us 90,000. It's equal to 1.6 times 1,800 will give us 2,880 s. Then we'll put the s on the other side, which will give us 1,080 s over 90,000. In order to solve for s, divided by, 1,080, 1,080, and s, speed of the Exante train will be, when we divide 90,000 divided, let's just do that in the calculator, I just didn't do that, which will give us 90,000 divided by 1,080, which is 83, which gives us 83 kilometers per hour for the Exante train. And to find the speed of the Paral train, it will be s minus 50. So 83 minus 50 gives us 33 kilometers an hour. So the important thing about setting this equation up is you want to set one of the variables to have all the changes. For example, it said that Exante train was 50 kilometers faster, and however, Paral train takes 60% longer. So therefore, you want all those changes to be stated on just one of the trains, not both. So some students may put, like, for the speed for the Exante train as s plus 50 and get this time for the Paral, which will give you the wrong answer. Okay, so always set all the changes in one of the variables, not both.